Hello, my name is Victoria Johnson, and this is my Milestone 1 code review for my CS499 Computer Science Capstone. In this video, I'll be walking through 3 different code artifacts that each align with a core area of computer science, which are software engineering and design, algorithms and data structures, and databases. I'll talk about what each artifact does, analyze some of its limitations, and share the practical enhancements I plan to make. Starting with category 1, which was software engineering and design, I'm using a Java class from my CS499 course called Contact Service. This class manages a simple in-memory list of contact records. The class starts by initializing the list in the constructor, which we can see in line 9 and 10. Essentially what this means is that all data is stored and temporarily and lost when the program ends. One key method is the add contact method, which starts on line 18. This checks if the contact ID already exists before adding a new contact. This logic is solid for a simple program, but it could be expanded with a more robust exception handling and better feedback for the user. The delete contact method, which starts on line 33, works similarly. It's looping through the list to find the contact and then removing it. Right now, the system is limited by the fact that there's no persistence or user interface. My plan is to add functionality to load and save contacts to a CSV file, implement a command inline menu so users can interface with the program, and refactor the logic to better separate data, filing, handling, and user interaction. Next, we will look at category 2, which is algorithms and data structures. I'm using the files from my CS499 course. It's a mobile app that I built for the course. The 2 files I'm focusing on are item SQLite handler and customer item list. In the items SQLite handler, the method getAllItems is responsible for retrieving all items from the database. This approach works, but it's not very efficient, especially as the item list grows. Every time this method is called, it retrieves all records and loops through them. In the customer item list, the adapter uses that list to populate the views. This displays logic, but relies on a potentially slow data backend. And that can be seen in reference starting on line 56. I'm going to optimize the query using indexes and replace raw SQL with prepared statements to reduce memory use and protect against SQL injections. I'll also probably introduce a hash map to cache frequently accessed items, which should improve performance during list rendering. Lastly, the third category, which was databases. I'm using a Python script called Animal Shelter from my CS499 course. This file connects to a MongoDB database and performs CRUD operations on animal shelter records. That is actually starting on line 7. I believe I may need to reestablish or reconnect the Mongo client. But for now, the one method that I'm going to be focused on is the read, which starts on line 21. It does the job, but it doesn't take advantage of MongoDB's performance features, One thing I plan to implement is indexing frequent query fields like animal breeds. I'll use MongoDB's transaction support for multi-step updates, like when an animal's status changes, or I plan to also add aggregation pipelines for reporting and filtering, such as counting animal groups by breed. But I believe that these enhancements will make the database layer much more robust and ready for a large-scale application. All of the changes across my 3 artifacts aim to improve performance, usability, and scalability. They also give me the opportunity to demonstrate key computer skills like OOD, algorithm optimization, and secure database operations. I really am excited to move forward with these improvements and include the results in my final ePortfolio. Thanks for watching.